This paper is about the source of wind-blown mineral dust that's deposited as loess on the Chinese Loess Plateau in north-central China. Wind-blown dust is a major component of global climate, so understanding its source is a critical part of understanding dust's impact on climate itself. This picture shows a site called Luochuan from the Chinese Loess Plateau, where you have thick dust deposits covering the early Quaternary. And this area of the Chinese Loess Plateau is about twice the size of the United Kingdom. So this is a huge amount of dust. A major question is, where is all this material coming from? In this paper, we're looking at a site called Beiguoyuan during the last glacial period on the northern end of the Chinese Loess Plateau. The Chinese Loess Plateau on this map is shown shaded in grey within the big bend in the Yellow River and adjacent to the Tibetan Plateau. To the north and the northwest of the Chinese Loess Plateau, you have a huge area of potential dust sources, including Gobi Desert, Sandy Desert, dried up lake basins, and high mountain areas. And the Loess Plateau is influenced by both monsoon and westerly winds, so there's a lot of potential areas and mechanisms by which dust can be transported to the plateau. So we originally sampled the site for high resolution 10 to 20 centimetre sampling interval luminescence dating, optically stimulated luminescence dating. The results of that are shown on the left hand side figure, which show the luminescence dates with depth to give us an age model for the site. Now the area shaded in grey yielded ages that were higher than those of the surrounding sediments, anomalously high ages. So we explored those in a bit more detail, and we found that they failed dose recovery tests, showed anomalous test dose behaviour, high DE values, and anomalous dose rates. So it looked like that these ages were not reliable, and something was changing in the properties of the quartz that we were dating. On this slide we see some of the figures in the paper where we've investigated the cause of this anomalous high set of ages. A major finding is that in many of these samples, in the luminescence decay, we see the presence of a strong ultrafast component, and that's shown on the diagram on the bottom part of this slide. And this to us suggests a key reason why the ages from this unit may be overestimated with respect to the other samples, which don't show the presence of this component. The presence of the ultrafast component suggests that we have quartz of quite different luminescence properties within that anomalous unit, and this suggests that potentially it's come from a different source. We looked at that in more detail by analysing the heavy mineral concentrations on the left hand side of this slide and the radioisotopic concentrations, which is shown on the right. In both cases we have very different properties of the sediment within the anomalously high age unit compared to sediment outside it. And again, this supports a change in source at this interval, and the characteristics of the sediment itself suggest that this may be a very localized, specific source. The combined luminescence dating and sediment analysis results suggest there's been an abrupt change in source at this site during the last glacial maximum. This seems to also be happening at about the same time as Heinrich Event 2, and implies that abrupt changes in dust source can occur on the Loess Plateau, and that these are short-term events potentially coincident with a large-scale climatic change. Now we're unlikely to see these events unless we apply very detailed high sampling resolution analysis, because they're very short-term. And luminescence dating is one way of doing that. But the problem there is that the presence of the ultrafast component in the anomalously high age samples makes the accuracy of these dates questionable over those intervals. At present, the cause of this source change isn't really clear, but it may be tied to perhaps extreme aridity that's occurring during Heinrich Event 2. But importantly, some of the key climatic proxies that we use from Loess, such as grain size and sedimentation rate, may be heavily influenced by these source changes themselves. So we need to be cautious when we actually use them to infer climatic changes, unless we know there's no source change at the same time.